In this presentation, we are introducing you to the basics of LTE and IMS network, and how GL's Maps test tool can be used to simulate different scenarios of an voice over LTE call. Let's start with the basic elements of an LTE IMS network. eNode B, also known as Evolved Node B, is an element in LTE access network that communicates directly with mobile handsets similar to BTS in GSM networks. Traditionally, a BTS in GSM network, or a Node B in UMTS network, has minimum functionality, and are controlled by an BSC or RNC. However, with an eNode B, there is no separate controller element. This simplifies the architecture and allows lower response times. Mobility Management Entity or the MME. The MME is the key control node for the LTE access network. It is responsible for mobility management. It is involved in the bearer activation or the deactivation process. It is also responsible for choosing the serving gateway or the SGW for a UE at time of the initial attach, and intra-LTE handover involving core network node relocation. It is responsible for authenticating the user by interacting with the HSS. The non-access stratum or the NAS signaling terminates at the MME, and it is also responsible for generation and allocation of temporary identities to UEs. It checks the authorization of the UE to camp on the service provider's public land mobile network or the PLMN, and enforces UE roaming restrictions. The MME is the termination point in the network for ciphering or integrity protection for NAS signaling and handles the security key management. A lawful interception of signaling is also supported by the MME. The MME also provides the control plane function for mobility between LTE and 2G or 3G access networks with the S3 interface terminating at the MME from the SGSN. The MME also terminates the S6A interface towards the home HSS for roaming UEs. Serving Gateway or the SGW. The SGW routes and forwards user data packets. This node also acts as the mobility anchor for the user plane during inter-eNode B handovers and as the anchor for mobility between LTE and other 3GPP technologies. For example, terminating S4 interface and relaying the traffic between 2G 3G systems and PDN gateway. PDN gateway or the PGW. The PDN gateway provides connectivity from the UE to external packet data networks by being the point of exit and entry of traffic for the UE. The PGW performs policy enforcement, packet filtering for each user, charging support, lawful interception, and packet screening. Proxy CSCF or the PCSCF. PCSCF is a SIP proxy that is the first point of contact for the IMS terminal. The terminal discovers its PCSCF with DHCP, or it may be configured in the ISIM or assigned in the PDP context. It provides subscriber authentication and may establish an Internet Protocol Security, IPsec, or TLS security association with the IMS terminal. It can also compress and decompress SIP messages using signaling compression, which reduces the round-trip over slow radio links. Interrogating CSCF or the ICSCF. This is another SIP function located at the edge of an administrative domain. Its IP address is published in the DNS of the domain, so that remote servers can find it and use it as a forwarding point for SIP packets to this domain. An example for this would be registering. It queries the HSS to retrieve the address of the SCSCF and assigns it to a user performing SIP registration. It also forwards SIP request or response to the SCSCF. Serving CSCF or the SCSCF. This is a central node of the signaling plane. It is always located in the home network. It uses diameter CX and DX interfaces to the HSS to download user profiles and upload user to SCSCF associations. It handles SIP registrations, which allows it to bind the user location and the SIP address. It sits on the path of all signaling messages of the locally registered users, and can inspect every message. It provides routing services, typically using electronic numbering or the enum lookups. It enforces the policy of the network operator. There can be multiple SSCFs in the network for load distribution and high availability reasons. It is the HSS that assigns the SSCF to a user, when it's queried by the interrogating CSCF. There are multiple options for this purpose, including a mandatory or optional capabilities to be matched between subscribers and serving CSCF. Policy and Charging Rules Function or the PCRF. This is a software node designated in real time to determine policy rules in a multimedia network. As a policy tool, the PCRF plays a central role in next-generation networks. The PCRF acts as a policy decision point for policy and charging control of service data flows, applications, and IP bearer resources. The PCRF selects and provides the applicable policy and charging control decision to the PCEF. Policy and Charging Enforcement Function or the PCEF. The PCEF acts as a policy enforcement point for policy and charging control of IP bearer resources. This functional entity is located at the gateway. For example, the GGSN in the GPRS case, and the PDNGW for Evolved Packet System. Breakout Gateway Control Function or the BGCF. The BGCF selects the most appropriate MGCF. For PSTN or circuit switched domain terminations, the BGCF determines the network in which PSTN or CS domain breakout has to occur, whether it is within the same network or in another network. Media Gateway Controller Function or the MGCF. MGCF is a SIP endpoint that does call control protocol conversion between SIP, ISUP or BICC, and interfaces with the serving gateway over SCTP. It also controls the resources in a media gateway or the MGW across an H.248 interface. Signaling Gateway. The signaling gateway interfaces with the signaling plane of the CS. It transforms lower layer protocols such as SCTP, which is an IP protocol, into MTP message transfer part, an SS7 protocol. This allows to pass ISUP from the MGCF to the CS network. Media Gateway. The media gateway interfaces with the media plane of the CS network, by converting between RTP and PCM. It can also transcode when the codecs do not match. GL's Maps supports simulation of all these nodes to achieve an end-to-end call simulation over LTE IMS network. Such a voice over LTE call can be within the same network or between two different service providers. As you can see here, each node can be controlled remotely by a centralized controller with a simple drag-and-drop operation. Here is an illustration on how maps can achieve simulation of UE roaming registration within the same network. Here is an illustration on how maps can achieve simulation of UE roaming registration between different networks. This is illustrating a simulation of a call from a non-roaming user to another non-roaming user on the same network. This is illustrating a simulation of a call from a non-roaming user to another non-roaming user on the same network. This is illustrating a simulation of a call from a non-roaming user to a roaming user across the network. This is illustrating a simulation of a call from a roaming user to non-roaming user across the network.